My name is Marcio Saito. I work for a company called Opengear, which is a company developing solutions for network resilience. Over the last 25 years, I have been working with enterprise customers and service providers, building infrastructure management solutions. And I'm not an expert on Chord, so what I hope to do here is provide an external perspective and some suggestions on how the existing management plane of the Chord architecture, how it can evolve to become more robust and more complete, as well as some advice to provide some advice to implementers of Chord so that, again, you build a network that's truly resilient. And I'm going to start with a story, a personal story from my past. If you work with computers to solve business problems in the late 80s or the early 90s, you're probably using a dump terminal, right? A VT100 terminal or a terminal connected to a mainframe. Those terminals didn't have any local processing capacity, and they need to be connected through a cable to a central computer, a Unix server or a mainframe. And at some point in the early 90s, with the emergence of Ethernet, we start creating this network appliance, which was a terminal server that connected dumb terminals through serial ports and then allowed them to connect to any server in the network. And I was a designer at that point, and this is a terminal server I helped to design around 1995. So it has 16 serial ports where you can connect VT100 terminals, and then it has a network connection. And then if you're sitting in front of one of those terminals, you can telnet and connect to any server in the network. And there was a small company, and we are struggling, networking company. In a good month, we would sell 20 units of this. In a bad month, we would sell 10 units of this, and it was very hard to pay for rent. And we were 3-4 people in the office, and I remember in 95, we are sitting there, and the fax machine starts printing something. And the salesperson goes to the fax machine, and she says, "Oh my God, someone is asking for a quote for 200 units of the terminal servers." And we were looking, and we thought it was a joke, because who would buy 200 terminal servers? And the name of the company was a funny name, and it was Yahoo. Yahoo was a startup at that point, right? There are 20 people in Mountain View, and they are building the first commercial internet data center. And they are asking for a quote for 200 terminal servers. So we went to talk to them. My boss, the owner of the company, wanted them to pay 50% in advance because we didn't know if they would pay, and we didn't know if we had money to manufacture so many devices. But I was very interested in why, right, they are buying so many terminal servers. And they took me to the first data center. Was a large warehouse, and they said there are about 2,000 servers running here. And what happens is, every day, if you're running 2,000 Linux servers, every day 4 or 5 of them are going to have a kernel panic and are going to crash. And once they become disconnected from the network, there is no way for you to actually recover them, right? So you have to get a crash cart, walk into the data center, connect to the console port of that server so that you can recover that server. And if you're talking about networking equipment, if you, for example, download the wrong configuration to a piece of equipment, the network doesn't work anymore. And again, if the network is not working, you cannot use the network to connect to the router or the switch to recover it. So what they want to do is they're going to use our terminal servers and connect all the serial ports right to the console port of those devices so that from a central location, without having to walk into the data center floor, they could manage and restore those devices back to functionality, right? And that was a very interesting experience. And what happened is, very shortly after that, the company, we changed our strategy, our positioning, and rather than sell, terminal servers for terminal access, we call the same product a console server, and we focus on network management. And since then, this was in 1995, Since then, hundreds of thousands of console servers have been deployed in data center and edge locations across the globe. And during that time, I was reading about the telco systems, the evolution of the telco systems, and I borrowed a concept from the telco world and brought it to IT. So we define out-of-band management this way. An out-of-band management system provides a secure alternate path so that a network engineer can reach the console port of any network device, even and especially when the production network is disrupted. And the basic concept is, if you rely on the network to manage your network, every time there is a disruption, you get a deadlock, right? And unfortunately, most of the network management software that you find anywhere is designed using networking protocols. And so the tool to manage a network is relying on a network protocol to reach the devices. And again, if you do that, then you get into trouble every time a device gets disconnected from the network or there is a disruption in the production network. And then if you come, more recent history, starting about 10 years ago, 2010, what has happened in the market is a concentration of IT complexity to the core of the network, right? So companies like Google and Facebook and Amazon, Microsoft, all those service providers, they start building these very large, very scalable hyperscale data centers. And within the data center, the core data center, the architecture is defined so that every hardware component is very reliable. The network is super hyper connected, so that even if a circuit is down or one specific connection is down, you never lose touch with that specific device. And so what happened is, though every single network device and every server in these hyperscale data centers, they do have a management port, right? They have a separate management port that's meant for out-of-band management. Because those data centers are so reliable, typically they are connected to the same physical network, right? So you are using the data plane and the management plane, the two logical planes, and you are collapsing them into the same physical infrastructure. And again, every time you do that, you run the risk of getting into a deadlock. And because those hyperscale data centers are so reliable, you should not, but you can do that, right? And all those companies, they are doing that. They do have separate logical networks for management and the data plane, but very often they are deployed and they are implemented in the same physical infrastructure, running the risk of a deadlock. And this does happen, right? So if you look at just a couple of months ago, Google had a major outage that lasted for about half a day and affected all the Google properties, the Google Cloud, the Google Mail, YouTube, and anyone using the Google infrastructure. And of course, I don't know the inside information on what happened during that day. But if you go read the public notice that Google put out, you're going to see that the way they describe the problem is that there was some problem in a configuration of some devices in the network, that wrong configuration created congestion in part of their network. And then the network engineers at the NOC, they try to solve the problem, and they're using certain tools that use the network to solve the problem. And they are saying that debugging the problem was significantly hampered by failure of tools competing over use of the now congested network, right? So even if you're running a hyperscale data center, even if all your network infrastructure is super reliable, if you collapse the data plane and the management plane into the same physical infrastructure, you get into that situation. Your network is not working. The tools you're going to use to fix the problem needs to use the network as well, and they are unable to do that, right? So when that happens, you need a manual intervention. You need to send someone to the remote location and things like that. So this happens even in a hyperscale data center. But when we go to the edge of the network, right, when WAN connections are much less reliable than a network connection inside the data center, and typically you don't have the levels of redundancy that you have in a hyperscale data center, this problem is even worse, right? So I was telling the story, and 25 years ago I borrowed from telecom and defined out-of-band management for IT infrastructures, and that's a definition that's still in use, still valid. What's happening now is that with 5G and with the move of IT infrastructures to the edge, the telco world is borrowing back from IT and adopting a lot of the practices, a lot of the platforms from the service that the service providers have been using for many years to provide internet services. And the big problem is, during this period of time, right, the last 10 years, a lot of the service providers, a lot of the people managing those networks, they forgot a little bit about the importance of keeping the data plane separate from the management plane. So when the telco industry borrows back from IT, we need to remind ourselves of the lessons, the telco lessons from the past, that we need to maintain that separation between the control plane, the data plane, and the management plane. And as a software-defined network is all about that separation, right? But we keep talking about the separation of the data plane and the control plane, and we forget that management plane is also very important, even more important, to keep separated from the other planes. And so the point of my presentation today is to use those lessons from the past, right, and see how we can apply that into the future. How can we apply that as we build the Chord architecture, as we deploy the network that's going to support all the edge services that we are going to need to support in the next several years. So this is again the same definition from 25 years ago, right? An out-of-band management system provides secure alternate path for network engineer, console port, any network device. This definition is getting old. It was defined 25 years ago, and we need to evolve and expand that definition. Why? First, because it's in this definition we are connecting people to ports, right? And as we move forward, we want to automate the management of the network. So we want to move from connecting people to ports, to extending the reach of automation systems, extending the reach of network management systems, right? So it's not about connecting people to ports anymore. It's about extending the management lane from the NOC, from the data center, to reach as transparently as possible all the points at the edge of the network. And second, it's not about connecting network devices anymore, because in the data center, compute nodes, they are not very critical, right? If a piece of hardware fails, a server fails, because of the virtualization and because of the cloud architecture, software workloads can move around, and the user doesn't suffer any interruption in the service. So recovering servers in the data center is not as critical anymore. But if you're talking about edge data centers where you might have 20 compute nodes at a location, if a server fails, you need to be able to recover them as fast as possible, right? So when we move to the edge, the importance of out-of-band management is actually going to come back and grow. And again, as the telco borrows from IT, we need to remind ourselves that everything needs to be manageable through a channel that is separate from the data channel. So I have been thinking about a new definition for out-of-band management systems, and this is my current thinking, right? We need to evolve and redefine that out-of-band management network. And I'm saying that a network resilience fabric, so it needs to be a fabric. It needs to be resilient to network failures, and it needs to extend the reach of other management systems at a central location to access remote infrastructure, even if the production network is disrupted or not yet established. Right? If we believe that every cell tower going to have a small data center in it, if we think that every central office is going to have a small data center in it, we need to make sure that we have that resilience fabric, right? That we can provision, we can configure, we can monitor, and we can remediate any problem that happens at the edge without having to send someone there. And the big problem we have today is that all the management tools, including the management tools we are using in the Chord design, they rely on the network to manage the network. So it's very important that we have that in mind. As I said, I'm not an expert in Chord, but in the last few weeks, I have been reading and researching and looking at the Chord design, the Chord architecture, and I'm very happy to see that the designers, the architects of Chord, they have thought about that, right? So you do see the separation of planes. You do see language talking about the user plane or the data plane, the control plane, and the management plane as separate entities. So the Chord project is trying to build an architecture and a reference implementation for the deployment of central offices redesigned as a data center, right? And as I said, there is language in the specification, in the presentations, that talk about the user and data plane as separate entities. And I was very happy to see that there is also a management plane in the design. So if you look at this slide, you have, so the red here is the data plane or the user plane where the user data is transported. And then you have the green and the blue. The blue is a switch that's supposed to be separate from the switches implementing the user fabric that connects to all the management port of every network device and to the management port of every compute node in the central office. And then there is a head node, which is a gateway that enables the access by a human operator, or local or remote, right? So basically the Chord architecture implements that definition of out-of-band management because it provides a way for a human operator at a central location to access the management parts of every single device at the central office, even if the user plane or the production network has a disruption, right? So Chord being designed by telecom architects already implement the traditional definition of out-of-band. If you look at what the head node is basically a server. In the reference implementation, the head node is a server running Linux and running additional software that provides the access gateway to the management fabric, and also the head node is used to do the provisioning, the bare metal provisioning of all the other devices in the Chord architecture, right? So you start with only hardware deployed at the remote location, you push information to the head node, and the head node is able to, using the management network, to provision all the devices from bare metal. And that's the way Chord is architected today. What I'm going to do now is, again, bring my experience from working with management plane for many years and attempt to provide a view, or at least my view, on how this could evolve, right, to implement a more resilient, a more robust management plane for Chord. And as I said before, I'm thinking about building a fabric that enables not only the day one provisioning of the infrastructure, not only the human access to the infrastructure, but that extends the reach of other automation systems, other management systems, so that they can work as if the edge location was at the central location, right? So to the who here is an architect of the Chord architecture? Who is working on developing Chord? One person. Who is actually implementing Chord or planning to implement Chord architecture? Maybe another person. Yeah, so I think when we think about the architecture of Chord, if you translate what I'm seeing, what I have been thinking for enterprise networks, I'm trying to translate how I see that evolving, right? So as network management becomes automated and distributed, there will be the need to deploy management applications at the edge for provisioning, monitoring, configuration, telemetry, for example, right? So there will be the need to deploy applications or agents, right, that are going to be performing management functions at the edge. And if you don't say anything, if the architecture doesn't define anything, what's going to happen is that the users of this architecture, they're going to see, well, it's an application, let me deploy it at some compute node that's available there. And again, if you're using the same compute node, right, to host user plane and management plane, you are collapsing the two planes. So it's very important that you run management applications, or you have a platform at the edge location that are dedicated to run management applications, and could be the head node, or could be dedicated compute nodes that are reserved for management functions. And they should be separate, and they should be designed, right, as part of the management infrastructure. So my suggestion for consideration is that we consider extending the current definition of the head node, which today is an access gateway and a day one provisioning server, to also include the ability to host post-provisioning management applications, right? So it's not only about day one, it's not only about bare metal provisioning, it's about running and managing and monitoring and configuring the central office, the edge location, beyond just day one. And as I said, it's no longer about connecting humans to ports. It's about extending the reach of the management systems. So every single network management software company out there is designing tools to enable the management of the network, but they are using protocols like OpenConfig and, or something similar to OpenConfig that are network protocols that run over the network. You don't want to force everyone to design management tools using protocols that are not network protocols, but you need to make sure that you provide a resilience fabric that makes those tools, right, to work at remote locations without them even knowing they are going through a separate network. Because unfortunately, all the network management applications, they do rely on network connectivity. So what you need to do is provide an alternate path that's resilient to failure, that doesn't share the same links, right? And perhaps if the links are down, you can establish a temporary connection, maybe using a cellular connection, maybe using some other type of connectivity, so that even if the production network is down, those applications can still be effective managing the remote site. And as I said, I work primarily in the enterprise networking space. I have a team working on both the concept of an automation gateway and resilience fabric. And I don't know exactly how to engage with the ONF community, and I'd love to engage and exchange ideas and experiences and see how, right, we can implement a resilience fabric in the Chord architecture. And to the users of Chord, the people, the carriers who are planning to implement the Chord architecture, I would call your attention to the fact that it's very easy for you when it comes to the implementation time to forget about that separation, right, and collapse data management. For example, you have VLANs, and if I'm implementing the architecture, why do I need two physical switches separate from each other, right? I can just segment the switch and using VLANs have this is production, this is management, and that's fine. But again, it's very easy in doing that when you realize that you have a disruption, you're going to find that a disruption in your production network also causes a disruption in your management network. So it's very important to pay attention to that separation all the way from the logical level all the way to the very physical level. Implementation time decisions can affect the separation of planes even when the basic architecture design is solid. So you need to pay attention to that. And in terms of slides, that's what I had. And I'd like to open and see if anyone has comments or questions about that topic.
Any questions?
No questions? Okay, so that's what I had. And again, I would like to engage with the community and exchange and discuss those ideas. So I'll be contacting ONF after the conference. But if anyone is interested in discussing that, we are very open to provide some of our thinking and then also learn from the community, because I'm sure in the ONF community there is a lot of people thinking about those topics. Thank you.